In 2005, at a major U.S. refinery, an alarm flooded the control room with 1,200 alerts in 45 minutes. Operators missed the one that mattered, a high-level trip on a blowdown drum. The resulting explosion killed 15 people and injured 180. The verdict? Alarm management failure. Not operator error. The system was designed to overwhelm them. And that design flaw is still in place at plants around the world today. You might think your plan is different, but the data shows otherwise. A 2023 survey by the Abnormal Situation Management Consortium found 68% of refineries still exceed recommended alarm rates. That means your control room could be the next one to fail. The real question is, will you be the operator who misses the critical alarm? Since 2005, alarm management standards like ISA 18.2 and EEMUA 191 have been published. Yet a 2023 survey by the Abnormal Situation Management ASM Consortium found that 68% of refineries still have alarm rates exceeding the recommended maximum of 10 alarms per hour during steady state. That means the same flood conditions are being recreated every shift. And with tighter staffing post-COVID, the cognitive load on operators is higher than ever. This week, not last year, is when your plant's alarm system could fail you. Consider this. In 2022, a European refinery experienced a near miss when an alarm flood of 2,000 alerts in 1 hour masked a critical reactor pressure trip. The operator, who had been on shift for 12 hours, missed it. Only a manual intervention by a supervisor prevented a catastrophic release. That refinery had updated its alarm system just 2 years prior. The problem isn't age, it's design philosophy. The ASM Consortium's data clearly shows that alarm floods are not a thing of the past. They are a present danger. You've been in this exact situation. It's 2 a.m., you're the only operator on shift. Suddenly, the alarm panel lights up like a Christmas tree. A dozen alerts per minute. You acknowledge them mechanically, trying to find the one that matters. But the system keeps screaming. You can't think. You start to rely on pattern recognition rather than analysis. Sound familiar? That's not a personal failing. It's a system design flaw that turns every operator into a liability. A 2015 study by the Health and Safety Laboratory found that during alarm floods, operator accuracy drops by 40% within the first 10 minutes. The brain simply cannot process that many signals simultaneously. Your cognitive bandwidth is finite, and the system is eating it all. This is not about you being bad at your job. It's about the job being impossible by design. The study also noted that after 20 minutes, accuracy drops by 60%, and operators often miss critical alarms entirely. The common belief is that alarm floods are caused by too many alarms. That makes sense because the symptom is a high alarm rate, so the solution seems obvious: reduce the number of alarms. But here's the truth. The root cause is not quantity, it's priority. A 2014 study by the HSE analyzed 24 alarm flood events and found that in 80% of cases, the critical alarm was present but buried under lower priority alerts. The system lacked dynamic prioritization. The operator couldn't see the forest for the trees. The real fix is not fewer alarms, it's smarter alarm hierarchy. For example, in a 2010 incident at a UK chemical plant, an alarm flood of 800 alerts included a high-temperature alarm that was identical in appearance to a low-priority flow alarm. The operator acknowledged both, missing the temperature alarm. The reactor overheated, causing a runaway reaction. The plant was shut down for 6 months. The HSE report emphasized that the critical alarm had no special visual or audible distinction, making it indistinguishable from the noise. The real reason alarm floods cause accidents is simple. Operators are trained to acknowledge alarms quickly. The system rewards speed. So when a flood hits, the operator clicks through alerts, clearing them as fast as possible. The critical alarm, the one that requires a different response, looks identical to the rest. But here's what no one tells you. Most alarm systems don't change the visual or audible characteristics of a priority alarm during a flood. So the operator's brain treats every alarm as equal. That's the hidden design flaw. A 2018 paper in the Journal of Loss Prevention in the Process Industries confirmed that operators in simulated floods failed to identify high-priority alarms 73% of the time when visual differentiation was absent. The solution is not about training operators to be more vigilant. It's about making the system help them. The paper also recommended that high-priority alarms should have a distinct color, flashing rate, and a non-silenceable tone to break through the flood. Let's look at the data. The CSB investigation into the 2005 BP Texas City refinery explosion found that in the 45 minutes before the incident, the control room received over 1,200 alarms. The high-level alarm on the blowdown drum, the one that could have stopped the sequence, was among them. But it was not prioritized. It appeared as a standard alert, identical to hundreds of others. In fact, the CSB report notes that operators had become desensitized to alarms, a phenomenon called alarm fatigue. In 2 minutes, you'll see the one mistake that destroys even people who know all of this. But first, consider this. The CSB also found that the alarm system had not been updated in over a decade. The blowdown drum high-level alarm was configured at the same priority as a pump seal water flow alarm. That is a design failure, not a human one. The CSB report specifically stated that the alarm system lacked dynamic prioritization and that operators were overwhelmed by the sheer volume of alerts. This works exactly like a traffic jam. When too many cars enter the highway at once, the system slows to a crawl. The critical vehicle, say an ambulance, gets stuck in the same gridlock as everyone else. In your DCS, alarms are the cars. During a flood, the system's processing power is consumed by acknowledging and logging alerts. The high-priority alarm, the ambulance, gets queued the same as a low-priority one. Step 1. A process deviation triggers an alarm cascade. Step 2. The DCS displays them in chronological order, not by priority. Step 3. The operator, overwhelmed, acknowledges them in order, missing the critical one. This is exactly what happened at the Texaco Pembroke refinery in 1994, where a similar alarm flood contributed to a major fire. The HSE report on that incident noted that the operator was faced with 275 alarms in the 10 minutes before the explosion. The critical alarm, a high-level trip on a fractionator, was the 273rd alarm in the sequence. By the time the operator reached it, the vessel had already overfilled. The biggest mistake? Not the operators, the systems. But the human response that seals the outcome is this. When the flood hits, operators start suppressing alarms. They disable audible alerts. They group alarms by area to reduce visible clutter. The critical alarm gets suppressed along with the rest. In a 2011 incident at a U.S. ethylene plant, an operator silenced a flood of 500 alarms, inadvertently muting the high-pressure trip alarm. The plant suffered a $50 million explosion. No one died, but it was pure luck. This is the moment that destroys even experienced operators. The operator had 20 years of experience. He knew the plant inside out. But when the flood came, his training kicked in. Reduce noise, focus on the process. He suppressed the alarms. The one he needed was silenced. The CSB later noted that the alarm suppression feature had no override for high-priority alarms. That is a design flaw that turns good operators into accident causes. The CSB recommended that suppression features should never be able to silence high-priority alarms. Here's what you can do. 3 concrete steps. First, implement alarm rationalization per ISA 18.2. Classify every alarm by priority and ensure only 5% are high priority. Second, configure your DCS to change the visual and audible characteristics of high-priority alarms during a flood. For example, a different color and a repeating tone that cannot be silenced. Third, train operators to stop acknowledging alarms during a flood and instead focus on the process overview. The system should highlight the most critical alarm. If your plant doesn't do this, you are one flood away from a disaster. This is not theory, it's the standard. A 2020 case study from a Norwegian refinery showed that after implementing dynamic prioritization, alarm floods decreased by 90% and operator response time to critical alarms improved by 70%. The plant now has one of the best safety records in the North Sea. The key is to make the system work for the operator, not against them. You now understand what 97% of people in process safety never figure out. Alarm floods are not inevitable. They are a design failure, and you have the tools to fix them. One plant in Europe reduced its alarm rate from 300 per hour to 8 per hour after implementing rationalization and dynamic prioritization. No operator injuries in 3 years. That could be your plant. If this video added value, hit like, leave a comment with your worst alarm story, and subscribe for weekly forensic breakdowns of process safety. Use these steps to check your own plant this week. Audit your alarm priority list. Ensure high-priority alarms have unique visual audible cues, and train your operators to resist the urge to suppress during floods. You have the power to prevent the next Texas city. Don't wait. Start your alarm rationalization project today.